Hey everyone, Mr. Kaczynski here. We're going to do the 3.3 practice your skills exercises. Well, let's get after it. Here we go. So we've got write a recursive rule for the second row of the table. So I think we're going to do it for more than just the second row. I think we'll do it for both time and distance. That's what the book's showing for the answer anyway. So we're going to start at 0, 4 and hit enter. So I think I'll type that in. It'll be easier. 0, 4, enter. And then we have to tell it what we want to do to each of those variables. So second negative sign gives us answer. Answer number 1 is our time, and we're going to add 1 second each time. And then answer number 2. What's going on here? It looks like we're losing 0.4 of a meter. So we'll say minus 0.4 and then enter, enter. That's giving me those values. All right, so back to this. Answer number 1, we're going to add 1, and answer number 2, we're going to subtract 0.4 or 0.4 each time, and then we'll click enter as many times as we need to. All right, sketch a graph of each walk, and then these walks that are described to us. Here we go. Start at the 1 meter mark and walk away from the sensor at a constant rate of 0.5 meters per second. Okay, so let's just do a quick sketch here. Do it in blue. We're going to do a 6-second walk. That's what 2, 3, 4, 5, 6. Start at the 0.5 meter mark, so we'll just do 6 by 6. Here's seconds. Here's meters. Oh, let's use these yellow points here. 0.5 would be right there. Okay. Oh, no, we're starting at the 1 meter mark. So right there. And a second later, we're at 1.5. Another second later, we're at 2. At 3 seconds, we're at 2.5. At 4 seconds, we're at 3. At 5 seconds, 3.5. And at 6 seconds, 4. So the walk would look like that. Start at the 3.5 meter mark and do not move. Okay. So 1, 2, 3, 4, 5, 6 seconds. 1, 2, 3, 4, 5, 6 meters. And this one's a lot easier because we're starting at 3.5, 1, 2, 3.5. And we're not moving. That means we're not getting any closer to or further from the sensor. All right, start at the 2 meter mark and walk in such a way that a graph of your walk contains the 0.33. This actually might be the easiest one we do. 1, 2, 3, 4, 5, 6. Oops, did I do too many? Yep. 1, 2, 3, 4, 5, 6. So we're going to start at the 2 meter mark, which is right here, and walk in such a way that your graph contains the 0.33. In other words, 3 seconds into our walk, we're 3 meters away from the sensor. So I'll go to 3 seconds, go up to 3 meters, and I guess I'll just connect that line through those 2 points. Write a set of walking instructions and sketch a graph described by 0.8 and this rule. Okay, so we're starting at 0.8. Well, I guess I might as well start typing it now, right? So the 0 and the 0.8 means start 0.8 meters from the sensor. We have to give a direction, and since it's plus 0.2, I know that we're getting further away from the sensor, so I'll say walk away from the sensor of 0.2 meters per second. So that would be our instructions. As far as our graph, all right, so we're going to start at 0.8, and then we'll be at 1, and then 1.2, and then 1.4, and then 1.6, and then 1.8. I mean, we're going to end at 2, so I mean, maybe the best way here is to just start at 0.8. And then 6 seconds later, 6 times 0.2 would be 1.2. So that would get us from 0.8 to 2. So that'd be right about there. So it's a very slow walk for sure. Each graph and table represents a walk. Okay, so we got all these. Arrange the 4 walks in order of starting distance from the sensor. Okay, so starting distance for this one is 2.5. For this one is 1. For this one, it's 6. And for this one, it's 1.4. So the order is graph 2, and then graph 4, then graph 1, and then table 3. Arrange the 4 walks in order of speed. That's a little tougher. So I usually use green for my starting point, and then I use red for my rate. So this one looks like every 1 second that goes by, we're getting 0.2 closer to the sensor. So 0.2 miles per hour. We can kind of ignore the negative with speed. All right, this one, every 1 second, we're getting 0.6 further away. So that's obviously faster. How about, what's a good way to do this one? All right, I see that point right there. So we went down a half and over, down a half a meter over 1, 2, 3 seconds. So let's calculate that out. Let's do 0.5 divided by 3. So negative 0.16 repeating meters per second is what that's measuring. And on this one, I think we can go with this point right here. And I can see that we've gone from 1 to 3 meters. That's an increase of 2 over the span of 1, 2, 3, 4, 5 seconds. So 2 divided by 5 is 0.4 meters per second. All right, so in order from slowest to fastest, looks like graph 1 is the slowest at the 0.16. Then table 3 is the next, is a little bit faster. Then graph number 2 at 0.4, and then graph 4 is the fastest, so although still pretty slow. Identify which walks are moving toward the sensor and which ones are moving away. And I kind of already have this answer because I can see those negatives. So 1 and 3 are, we're getting closer because we're getting closer to 0 with our distance, and 2 and 4 are getting further. So let's say 1 and 3 toward, and 2 and 4 away. All right, that's all I've got for you today. Good luck on this, and hopefully it helped you find some mistakes. Adios.